Today, we're diving straight into a totally mind-bending scientific paradox buried thousands of miles right beneath our feet. Because as it turns out, according to the strict laws of thermodynamics, the very center of our planet, Earth's solid inner core, technically shouldn't even exist. Let's get into it. You know the classic textbook story, right? We've got this molten ball of liquid metal at the center of the Earth that's been slowly cooling down and crystallizing over 1 billion years, growing steadily outward. Simple enough. But researchers recently realized this standard story is completely ignoring a massive thermodynamic roadblock known as the nucleation barrier. See, in chemistry, metals don't just magically start crystallizing the second they get a little bit colder. They need a massive drop in temperature. Think about trying to freeze an ice cube in a glass of water. Even if that water is sitting at exactly 32 degrees Fahrenheit, it can take hours to actually freeze. To speed that up, you literally have to supercool the water or drop a pre-existing piece of ice into it to force the process and lower that nucleation barrier. Well, pure liquid metal in the Earth's core needs a similarly huge temperature drop to spontaneously crystallize. So what kind of drop are we talking about here? At the extreme pressures of the Earth's core, pure liquid metal would need to supercool by an absolutely astounding 1,000 degrees Kelvin to just spontaneously freeze. And here is where the math totally falls apart. The scientific community estimates that the Earth's deep interior only cools by about 100 degrees Kelvin every billion years, which means reaching a 1,000-degree drop is essentially a thermodynamic impossibility. So, how on earth did the core freeze? I mean, if it couldn't simply cool down enough to form on its own, something else had to have kicked the whole process off. This total paradox puzzled scientists at Case Western Reserve University, and it sent them searching for a mechanism that could bypass this impossible supercooling requirement entirely. And that search birthed a pretty wild new theory called the seed hypothesis. The researchers laid out this fascinating 3-step solution. Step 1, a massive chunk of solid metal alloy actually breaks off from the mantle. Step 2, it plunges deep into the liquid outer core. And Step 3, it manages to survive the journey all the way to the center, acting as a seed to artificially lower the nucleation barrier and kickstart rapid crystallization. It's exactly like dropping that ice cube into a glass of supercooled water. But here's the catch. To actually survive that unbelievably intense plunge to the center of the Earth without just melting and dissolving along the way, this metal droplet would have to be completely massive. The scale here is literally mind-blowing. We are talking about a metallic nugget with a 10-kilometer radius. That means dropping a chunk of solid metal roughly the size of Manhattan straight into the center of the Earth to act as a seed. Crazy, right? But wait, the mysteries of the core do not stop there. Prepare for a second, huge scientific twist. Because we were all taught in grade school that the Earth has 4 distinct layers: crust, mantle, outer core, inner core. Simple. But recent discoveries have actually revealed a 5th layer. It's a distinct, solid metallic ball located at the very center of Earth's inner core, now known as the innermost inner core, and it features a completely different iron crystal alignment from everything around it. Now, you might be wondering, how do we even know this 5th layer exists? We obviously can't dig down there. Well, seismologists from the Australian National University use this brilliant method of measuring Earth's echoes. They stacked up bouncing seismic signals triggered by over 200 massive earthquakes, we're talking magnitude 6 and above, from the past decade. These seismic waves actually ricocheted back and forth through the center of the Earth up to 5 times. By probing the core from all these different angles, they revealed varying wave speeds, which are caused by entirely different iron crystal structures in that specific centermost region. I really love this quote from Professor Hravoj Tkalčić, who led that research. He said, "This inner core is like a time capsule of Earth's evolutionary history. It's essentially a fossilized record of our planet's past. The inner core isn't just some static, boring hunk of metal. Its distinct layers prove that a major global event permanently altered its crystal structure, which naturally sets up the ultimate question for us today. When did this actually happen? How do we date the birth of the inner core? How can scientists possibly determine the exact timeline of a Manhattan-sized metal seed freezing the core 500 million years ago? Well, to find the answer to that, we actually have to stop looking deep underground and instead look at ancient rocks scattered right here on the surface. It turns out the secret is hidden in early Cambrian plagioclase crystals from the Glen Mountains layered complex in Oklahoma. A study out of the University of Rochester found that these specific crystals contain microscopic magnetic needles, just 200 nanometers wide. And these tiny needles acted like perfect little compasses, completely trapping and recording the exact strength of Earth's ancient magnetic field as they cooled hundreds of millions of years ago. So let's trace the timeline of Earth's magnetic heartbeat captured by these microscopic needles. Around 565 million years ago, during the Ediacaran period, Earth's magnetic field had weakened to an ultra-low state. It was basically on life support, on the verge of total collapse. But then, right around 550 million years ago, the inner core began to nucleate, or freeze. And by 532 million years ago, in the early Cambrian period, the magnetic field had experienced this sudden, massive geodynamo revival. The sheer scale of that revival is absolutely staggering. The data from those single crystals showed that the magnetic dipole moment, which is the overall strength of our magnetic field, became 5 times stronger in the early Cambrian compared to that ultra-low period just a few tens of millions of years prior. This kind of rapid, explosive recovery is exactly what you'd expect if a massive inner core suddenly started growing and churning all the liquid metals around it. The onset of that core nucleation unleashed a massive amount of latent heat and buoyancy. It acted like a giant planetary growth spurt that permanently reshaped the deep mantle and essentially saved our magnetic shield. And what's really cool is that deep mantle structure still persists today. It controls exactly how heat flows out of the core, dictating the seismic signatures we're measuring right now. Okay, which brings us to the final piece of the puzzle: J-waves. For 80 years, scientists theorized that if the inner core was truly solid, it should transmit specific types of seismic shear waves called J-waves. But they were incredibly elusive, completely hiding out in the direct seismic wave field because their amplitudes were just so incredibly small. Recently, however, researchers devised a completely new method to detect them hiding in the background reverberations of earthquakes, a phenomenon known as the coda correlation wave field. So, what did these elusive J-waves finally prove? Well, they confirm for sure that the inner core is indeed completely solid, but paradoxically, it's actually kind of soft. The shear wave speeds and shear modulus, which is just how we measure rigidity, show that the inner core's rigidity values are about 2.5% lower than the standard models we've always accepted. So it's a solid metallic heart, yeah, but a relatively soft one, which opens up an entirely new world of dynamical interpretations for our planet's deep interior. We've gone from an impossible supercooling paradox to a Manhattan-sized seed to a newly discovered 5th layer of the planet and an ancient magnetic time capsule trapped in microscopic needles. It's a lot. So I'll leave you with this. If the solid heart of our world is still hiding this much from us, what other mysteries are buried miles beneath our feet? The Earth is a deeply dynamic machine, and we are clearly just scratching the surface. Thanks so much for joining me on this explainer. Keep wondering, keep learning, and I'll catch you next time.